Alright students, this is the second video for the test review on page 2. If you have not yet read problem number 9, please go ahead and pause the video and read it at this time. So in this problem, we're referring to a coyote trying to catch the roadrunner, where usually something's happening like he's doing something stupid like trying to throw something off a cliff to be able to hit the roadrunner as he runs by. So we can see that this model is a parabola, that we're given 3 different functions. And it says, does Molly have 3 unique equations that model the same equation? So basically it's asking, are the functions equivalent? So the first thing you should do is type each of your functions into y equals. So you type each of your functions in and then check the table. What will probably happen is you'll be able to identify any that are alike. So notice that as I scroll over, up here at the top it says y1 then y2. As I scroll to the right again it says y3. And notice that all of our table values for y1, y2, and y3 are the same. So that means that yes, they are all equivalent. So to answer this question, I would expect you to state something about them being equivalent. So does she have 3 unique equations? Yeah, they're unique because they look different, but are they the same? So yes, they are all equivalent. And you can say when graphed, so like when we try to put them in y1, y2, y3 to graph them, are y1, y2, and y3 matched? And that's good enough there to explain why they are the same. So then I ask, what does it mean for equations to be mathematically equivalent? So basically they're in a different form, but they have the same value. So we can say they have a different representation or a different form, but they are the same equation or function or expression if it was an expression. So same equation or function. So memorizing these answers, I would suggest it. Next it says, which of the equivalent equations would be most helpful in answering each of these questions? Explain, then answer the question. So we are asked, when does a coyote hit the ground? That would be here, meaning we need zeros. What is the maximum height? That would be up here when he reaches a max height. That's called the vertex. And when did he launch himself off of the cliff? That would be the initial height, or the y-intercept. So let's think back to what we already remember about these forms. We know that this form here is what we call factored form, and that if we wanted to find the zeros, we set each factor equal to 0 and solve. So that means time equals +4 and -2. But if you think about it, can time really equal a -2 seconds? It can't. So the only one that's going to be relevant is 4 here. In this case, this is called standard form. And remember, the most important thing we can identify in standard form is the y-intercept, which is the constant term. So let's just put up here our y-intercept, or initial value, is 256 feet in the air. Let's assume seconds and feet here. And then lastly, we call this vertex form. We like this form because it's easy to identify the vertex as 1 and 288. So remember that your x values here, your input is time, and specifically time in seconds, and that here, this represents your height. And let's assume feet here. It says up here, cliff is measured in feet, coyote's time is in seconds. Okay? So because we understand all that, we can determine which equivalent equation would be most helpful for identifying when the coyote hits the ground. So pay attention to when it says when, that means time. If it says what is the max height, then we want the height in feet, right? And then at what height did he launch himself off the cliff? So that, again, is going to be our y value here. So I'll just put in here y. So when does he hit the ground? Well, he hits the ground right here, but that's when we want our zeros. So we want the form that shows us our zeros, which is factored form. So to answer this, I want you to be really clear on the question. It says, which equation is most helpful? Explain why it is, then answer the question. So there are, each one of these questions is 3 points because there are 3 parts to each question. So which of the equivalent equations would be most helpful for determining when he hits the ground? That's going to be factored form. So your first answer, factored form. Why? Because factored form shows the zeros. When does he hit the ground? He hits the ground at 4 seconds. And you have to put units. Okay? Next, what is the maximum height? So max height, again, we need our vertex form. So the first answer would be vertex form. We want that equation. Why do we want vertex form? Because it shows the vertex, which is our maximum height. And what is the maximum height? So that means from our vertex, what height would be 288? When does it hit that height? At 1 second. But we need to know that. It's 288 feet. And when will it occur? So it occurs at 1 second, and that comes from 1 and 288. But understanding that that's time and that's height. Okay? And next, at what height did Coyote launch himself off of the cliff? Well, he launched himself off of the cliff to start with right here. So that's our y-intercept. Which equation shows our y-intercept? Standard form. So we want standard form. Why do we want standard form? Because the constant term is the y-intercept, which is your initial value. And what is our initial value? The initial height was 256 feet. Okay? And that concludes problem 9. I can go ahead and tell you that I'm going to omit number 10 from the test. So you all will be able to finish in time. So we'll skip 10 for now. Let's move on to 11. It says the height of a child's bounce above a trampoline is given by this function. Rewrite to reveal the max height and how long it takes, and then reveal how long it takes to reach that max height. So max height, that should remind you of vertex. Well, that means I need you to write this function in standard form in vertex form. So now we're kind of going back to doing the steps just like we did on number 4 on the front side of the page. The first step would be to remember to continue to bring this down, f of x or y equals, either one is fine. I want you to first put parentheses around your quadratic and linear terms. Remember, your negative 16 should be at every step, or we're not creating an equivalent equation. If I divide both terms by negative 16, I'm going to end up with t squared. And then negative 32 divided by negative 16 is negative 2t. I then have to add a number when I complete the square, and then I just bring my negative 3 down. This is when we take half of b and square it. So half of 2 is 1. 1 squared equals 1. Now, don't forget, you've got to figure out, well, what did I bring into the equation? If you multiply a by this new value, it's negative 16 times 1 is negative 16. I have to preserve equality here by doing the opposite, so I need to add 16. So again, I'm bringing my negative 16 down so I don't forget it. Now we want to factor, so square root, keep the sign, square root. So we'll have t minus 1 quantity squared, and negative 3 plus 16 is positive 13. So now this is in vertex form. That's part of what you had to do. It says rewrite the expression to reveal the max height and how long it takes. So that means our vertex is keep switch, so 113. What that tells us is that at 1, again, this is similar to the other one, time and height. It means it reaches a max height of 13 feet at 1 second. Okay, so I need vertex form, and I need a statement stating that you understand what that vertex form is telling you, that it reaches a max height of 13 feet at 1 second. And that's going to conclude this video.